Before we start this video, do like and subscribe to our channel and not miss on any updates.
So the topic for the day is multiple regression, and I'll start with a recap of what we have done in the level one, because knowledge of that shall be required when we are doing a level two multiple regression as well. ठीक है? तो कहीं ना कहीं उसका solid base चाहिए होगा to utilize it for the coming part that we're going to study about. ठीक है? So first I'll start with the very basic so that you feel comfortable with the topic. So, what is regression? Why were we doing regression at the first place? Do you remember what was the objective?
So you can predict the movement after placing a few points on the graph.
Exactly. So, objective of regression is to make prediction, right? You wanted to make a prediction कि यार, let's say today we have India Australia final for the World Cup. I want to make a prediction that who is going to win, right? So I can do that using a regression model. I can do that using a regression model so as to make a prediction that who is going to win. Or let's say one of my friend works at Reliance. Now they build predictive models. They build predictive models to make a prediction on the future prices of Reliance crude oil. Sorry, on the crude oil, so that Reliance can accordingly take a position in the market, right? So regression as a concept has overarching. Chandu, if you can please mute yourself, or if you want to ask something, you can ask. Okay, thank you. So regression has an overarching uh, deployment in every industry possible, because at the end of the day, what we want to make a prediction and we want to be right. So regression is a great tool in that aspect. Okay. Now, how we were doing regression, we were somewhat making such this kind of equation. If you remember, yi equals to a1 plus b1 xi. For what I hope you are able to recall from the previous level. So yi equals to a1 plus b1 xi, या फिर इसको ऐसे भी जैसे बुक का जो नोटेशन है yi equals to b0 plus b1 xi, right? So this used to be called as the dependent variable, and this was our independent variable. And let's take an example. Let's say that I want to predict what marks you're going to get, Jeremiah, using this model. So what I can do, yi can be the marks that you're going to get, and xi could be the number of hours that you have studied. So depending on the number of hours that you have studied, I am trying to make a prediction that how much marks Jeremiah is going to get for a particular examination. Now this is also one regression model. But in this model so far, there's one thing, which is that in the entire model for us, there's only one predictive, one independent variable, which was number of hours, which was number of hours. I hope you are able to see ये जो xi जो था हमारा, the xi which was given over here was only one independent variable. So that is why it was called as linear regression. Linear regression. There is only one independent variable. But let's say when I'm building a model using multiple variables. So for example, I'm saying that I'm saying that uh, the marks which you're going to get in the exam, the marks which you're going to get in the exam are not only dependent on number of hours that you've studied, but they are also dependent on the sleep which you're getting, the nutrients which you're taking, They are also dependent on the hours you spent in office. If they are beyond a certain level, then obviously your study time would be impacted somewhere, right? So the hours you spent, number of tests which you have given, mock tests which you have given. So let's say if I'm saying that your marks is not dependent just on one variable, but on multiple variables, and using those multiple variables, I'm trying to build a predictive model, then it becomes some sort of a multiple regression model for you. Multiple regression model for you. Yi naught equals to b naught plus b1 xi plus b2 x2 plus b3 x3. So this becomes your predictive model. This becomes your predictive model. Okay. I hope it is clear till now. Any questions? Anything that comes to mind?
No, sir, nothing.
Okay. Okay. Just once. So this is like a very basic of how multiple regression works. Okay. मेजरली कोई भी रिग्रेशन मॉडल होता है उसका पर्पस ही होता है कि हम ये समझ सके दैट वी आर एबल टू अंडरस्टैंड what kind of relationship is there if there's if we are getting some sort of output, if we are getting some sort of yi over here, if we are getting some sort of yi over here, is it even dependent on this xi's or not? If there's act if there's any actual relationship between these xi's. Do you remember the hypothesis testing that we used to do? थोड़ा याद है or have you forgotten? No?
No, sir, I can't remember exactly.
That's okay. You'll require a lot of it in this level. So it's better to, touch upon these topics
Mhm.
again and brush up yourself,
Yes.
right? So we used to do hypothesis testing to understand and to make sure that whether these, variables have some sort of statistical significance or not. Whether these variables have some sort of statistical significance or not, so as to make sure that if we are using them in the regression model, they have some predictive power. They have some predictive power. Let's say if I'm saying that your marks are going to be determined by the, let's say, the weather which is there. The weather in, you are from Bangalore?
No, sir, Goa.
Sorry?
Goa.
Goa. Okay. So I'm saying that, let's say, Jeremiah's marks in exams are going to be determined by the weather in Goa. Now, that is not a very logical, relationship. That is not something which is going to impact that I know on a logical level. But what about the statistical significance or what about the stats behind it? Okay. So in that case, what I'll do, I'll try to test the hypothesis that my H naught would be at B1 equal to 0. And my H alternate hypothesis would be that B1 is not equal to 0. And then I do the statistical testing where I try to understand whether this relationship, whether my null hypothesis can be rejected or not, and whether this xi variable that I'm talking about is actually significant in the relationship or not. I hope you're able to recall now a bit, right? So that is how we used to do statistical testing at that time. Okay. Okay. So the purpose of the initial session would be like a warm-up session for you so that you feel comfortable with, everything which was done earlier. Thoda recall you're able to recall things and then we are able to build upon that. Okay. I'll ask you a very important term and I would like you to answer. Do you remember what was error term? Symbol was EI not. What
Uh,
was error term? Residual term or error term?
so the variance from the point which we have predicted to the actual point on the line.
The variance of it or the difference of it?
Difference of it, I can't get what the exact term would be, but if we plot the line like this, the residual error basically.
Perfect. Perfect. So basically, let's say this is my regression line, and let's say on this particular xi, regression line is saying that the y value should be this, right? Let's call it y1 naught, right? But the actual realized value is, let's say, somewhat this. I'll change the, the actual value is somewhat this, which is, let's say, yi. Now the difference between yi minus yi naught is basically what? My error, right? Error or the residual, or error or the residual. So basically, the residual is only the difference between the actual value and the observed value using the regression model, using the regression model, right? And as a analyst, our objective is not to build a model which is just directly one to one with respect to the with respect to the actual value, with respect to the actual values. Our objective is to make a model in which the error difference can be as least as possible. I mean, we know that it is very difficult to make an exact model which can predict the actual values correctly, but we want to be as close as possible to the actual values using our model, and that is our objective as an analyst, right? Okay. Now, recalling things from hypothesis a bit more again. So, do you remember what is p-value? What is p-value?
Um, it's from the table you take it.
Yes. Okay. So let's say I am testing for 95% level of significance. Right? So I'm just trying to, challenge your understanding of level one again and again. So you might feel, okay, why I'm, put in a spot. So, okay. So unfortunately, you are the only one right now. So you are definitely going to put in a spot a lot more. Let's say I have 90%, 95% level of significance. Okay. I'm testing on that. What are going to be these areas, the cutoff areas? We are doing a two-tailed test. So what are going to be these areas?
The residual error, which
No, no, no.
the thing, the
Okay.
point can lie in those areas.
Yeah, yeah. So iska, they're used to certain values, right? 1.65, 1.
Yes.
Yeah. So what is going to be this value is what I'm asking.
5% of the 0.25% of the observations will lie on the
Yes.
left and right side.
Correct. That is correct. Now this value would be 1.96 and minus 1. Sorry, 1.96 and minus 1. Right? This used to be a cutoff value, right? And if we were getting the z value beyond this, then we are saying we will reject the null hypothesis, right? Are you able to recall now? Right? See. So I'll just add a page. Okay. So this is my, chart, and I'm saying that 2.5% values lie beyond this, and 2.5% values lie beyond this. I'm doing a two-tailed test. I'm doing a two-tailed test. So if I'm getting the p-value, let's say 1.3%, then I'm lying somewhere over here. Then I'm perhaps lying somewhere over here or either over here, right? Which is in the rejection region. Which is in the rejection region. Which is in the rejection region. Which is in the rejection region, right? So I'll reject my null hypothesis in that case. I'll reject my null hypothesis in that case. Able to recall now? Getting in the groove, comfortable with the topic a bit? Okay. See, level 1 and level 2 are a bit different in their approach, in the sense that in level 1, topics were not related, right? You won't find any synchronization of, let's say, topic 1 with topic 2, topic 2 with topic 3. And even amongst subjects also, even amongst, let's say, equity in corporate finance, uh, equity and somewhat of some will let's say portfolio or quants and portfolios. As you won't find any correlation in level one. There's not much relation of one subject with other. But in level two, what will happen? You will there shall be a tendency of topics being related a bit. So you might require knowledge of one topic in the next topic, right? So let's say if you have read about free cash flow in, let's say, equity, the knowledge of free cash flow shall be required when you are approaching corporate finance also. In some small bits, not major, but some small bits. Okay. So and some base or level one shall also be required. So it is always advisable that you always keep a solid background in every topic in level 2. Level 2 has less questions and more concepts. So that is one challenge with level 2, right? So when I came a level 2, one thing which I had to do was revise concepts continuously. Okay? So your approach has to shift a bit in level 2. Okay? Okay. Because among all the levels, level 2 is the one which is really the most difficult. I'm not scaring you, but just giving you facts. Okay, sorry. Yi equals to a1 plus b naught x1 plus b1 x b1 x1 plus b2 x2 plus b3 x3, right? Now this is a typical multiple regression equation for you. Okay, this is a typical multiple regression equation for now. In this equation, this is our what term? The intercept. The intercept, and these are known as the coefficients of the term. These are the coefficients of the term, right? And using these coefficients, let's say I want to understand whether these have any statistical significance or not, on all those sort of hypothesis testing that I want to do. General equation of null hypothesis: b1 equal to b2 equal to b3 equal to 0, and alternate is b1 or b2 or b3 is not equal to 0. That's a very general hypothesis that we generally do, right? Okay. Now let's say that yi equals to, I'm just taking a bit of you know simple regression or linear regression, then I'll go to multiple. Okay. A1 A1, yeah, I would just put up a number. yi equals to 11.6 plus 0.25x, right? Now my question to you is, what is the meaning of this 0.25? What does this 0.25 indicate? What does this 0.25 indicate over here? This is 11.6. Okay. The intercept term is 11.6. My question to you is, what does this 0.25 indicate over here?
So 11.6 will be where it intercepts. 0.25 is the slope, and
Correct.
x will be your independent variable.
Absolutely.
What
So
will
now
be the sum?
what I'm trying to ask you is, in terms of this regression equation,
Hmm.
what is the significance of 0.25? When we are saying a slope or something, so what does it mean?
Means the x variable by the y variable.
Yeah. So can I put it this way that if yi equals to 11.6 plus 0.25x, you are from maths background or non-maths background?
Math background.
Maths background, right? So if I do this, that would be 0.25,
Hmm.
right? So that means if x value is changing, then y value is changing by 0.25 always,
Hmm.
right? Or even if someone is from non-maths background and watching this, can I say that if I'm changing x variable by 1, if x variable is changed by 1 unit, then the change in y variable shall be always 0.25. Let's see how it is happening. Let's say x की कोई value लेते हैं. Let's take 1 and 2 for x. ठीक है? Do you have a calculator handy with you?
Hmm. Yes.
Okay, ठीक है. I'll want you to do few calculations for me. Okay. So y, oops, sorry, yi equals to 11.6 plus 0.25x. If x is equal to 1, please tell me the value of y.
11.85.
11.85. If x is equal to 2, what is the value of y? Please tell me. 12.1, I guess.
12.1.
Right? What is the difference?
0.25.
1 to 5. What is the difference?
1.
Let me change it to 3 now. Tell me the value of y, please.
It's 12.35.
What is the difference?
0.25.
What is the difference?
1.
So whenever x is changing by 1 unit, the change in y is always 0.25, which is your slope. Right? This was with respect to the simple regression that we would do, right? Or the linear regression that we used to do always in our previous level. Okay. But in level 2, we have multiple regressions. So now in multiple regression, how the interpretation works, let's try to understand. Okay. Yes. So in the case of multiple regression, you have an equation given like this. Y equals to 11.6 plus, let's say minus 11.6 plus 0.25 x1 plus 0.14 x2. ठीक है, minus 11.6 plus 0.25 x1 plus 0.14 x2. Right? Now we have to interpret the significance of this. So what do these terms mean at all? Okay. So first thing is clear, ki, sir. This is my intercept term irrespective. So there's no problem with respect to this, right? This is our intercept term always. Now what about the other variables? Now in the case of other variables, this 0.25. What does this 0.25 indicate? So 0.25 indicate what shall be the change in the y value or the dependent variable for 1 unit change in the independent variable of this x1, for 1 unit change in x1, holding this x2 as constant for that particular period of time. Holding this x2 as constant for that particular period of time. The 0.25 indicates what shall be the change in y when x is changed by 1 unit, holding this x2 as always constant. So that's why when we used to talk about simple regression, we used to call them as slope, or we used to call them as slope coefficients. Okay? But in the case of multiple regression, these are called as partial slope coefficients. They're known as partial slope coefficients, which never used to happen in the case of simple regression. We used to call them as simply slope coefficients. Yeah, slope. We used to call them as slope coefficients and or slope. But in this case, this shall be known as partial slope coefficient. I hope you're comfortable and clear.
Yes, sir.
Okay. So I'm taking a small equation for you. Okay, yi naught equals to 1 plus 2.5 x1 plus 6 x2, 8. Now, can you please give me the interpretation of 6 over here?
per unit change of y, no, per unit change of uh, x2, y will change by 6 times x2.
6 times x2 means 6 units.
6 units.
6 units holding x1 constant. That
Holding
is very
x1.
important,
Hmm.
right? So even in your exam, you might get a question that okay, you are given a certain equation, you're given a certain equation, and they might ask you that what is x2, or sorry, what is 6 in this question. So 6 is basically my partial slope coefficient, which basically means that what is the change in y when x2 is changed by 1 unit, keeping x1 constant. Now see how questions are built in exam. What they'll do, they'll give you three options. Some may they will mention this, and in one of the sentence they will mention holding x1 as constant. So that is going to be the right answer. So they're always very close options, right? So just keep a note of that always. Okay. Now we come to LOSC for you, which is, so we are done with LOS A and B till now, which was like a warm up for whatever you have done, and a bit of multiple regression here and there for you. Okay. Now we are actually coming to the main building block for us. Okay. Now we are coming to LOSC. Okay. And till now you are comfortable with the topic. थोड़ा flow बन पा रहा है. You are able to establish a flow for yourself in the topic.
Yes, yes.
Able to recall everything.
Hmm.
Okay. ठीक है fine. Now we are coming to the discussion on the assumptions for linear regression. Do you remember any of, for regression per se? I won't even say linear regression. Do you remember any of the assumptions, or have you forgotten?
No, sir, I don't remember.
Okay, okay, then self point. So I'll take you gradually through each and every assumption. So first assumption was that there's a linear relationship, between independent and dependent variable. There is a linear relationship between independent and dependent variable. What does it mean, sir? Y equals to A1 plus B1, X1 plus B2, X2 plus B3, X3 plus B4, X4. This is my this is my linear relationship between dependent and independent variables. These are what? My independent variables, and this is what my dependent variable in this case. This is what my dependent variable in this case. Now, this is a linear relationship. Linear how? Because the power of x's over here is just 1. Let's say if I change it to, let's say, x2, x3, x1, x4, right? X raised to power 4, x raised to power 2, x raised to power 3. Now this is becoming more of a parabola kind of thing. This is no longer a linear relationship for us. This is no longer a linear relationship for us. So this is not something which we can call as a, which can be used for multiple regression. In the case of regression per se, we need to have always a linear relationship. The relationship has to be linear between the dependent and the independent variable. I hope it is clear. Comfortable with this?
Yes, sir.
Because you see more the anything that I'm putting out right now is related to the kind of exam questions you are going to get also. Okay.
Hmm.
So you need to be very thorough with all these things, because I know how do they play uh, MCQs in the exam, right? So generally questions इसी framework में build कर रहते हैं. ठीक है? Sure.
Okay.
First is that there is a linear relationship between dependent and independent variable. Now, what is the second point? What is the second assumption which is given over here? That all the residuals are normally distributed. Are normally distributed. Okay. There's always all the residuals have they fall in this normal bell-shaped curve. The purpose of having this assumption in our analysis is that it makes a lot of predictive modeling easy as we go further into this. As we go further, a lot of predictive modeling becomes very easy if this assumption is being adhered to. If this assumption is being adhered to, a lot of predictive modeling becomes much easy for us. Okay. The third assumption used to be that the variance of error term is constant for all observations. Is constant for all observations. Variance is constant for all observations. What does it mean? That your error term is not hyperventilating. It's not something like this. Okay. So for this xi, it is over here. For this xi, it is, let's say, error term is over here. For this xi, the error term is over here. For this particular xi, the error term is somewhere over here. ऐसा नहीं हो रहा. The error term is fairly constant. I would say fairly variance of the error term is fairly constant for all observations, so that we are able to have a fair model. We are able to have a fair model, and there's not much diversion amongst the error terms varies. Not much diversion among the error term varies. So variance of the error term is fairly constant for all observations. Okay. The fourth, I would say assumption, which is perhaps very important, okay, is that residuals are not correlated with each other. So let's say for one particular independent variable, I'm getting a residual E1. For second variable, I'm getting an E2. For third variable, I'm getting E3. So these residuals are of each one observation is not correlated with the residual of another observation. There's no correlation among the residuals. Okay, there's no correlation amongst the residuals. Okay, and in fact, these residuals have no correlation with the yi as well, with the yi as well, with the predicted value as well. There's no sort of correlation amongst these values as well. I hope you're clear. Any doubt till now?
No.
Okay. The fifth and the last observation is that fifth and the last assumption is that the independent variables are also not random. Now this is a very interesting, assumption. So what does it mean that independent variables are not randomly thrown into the system? That xi cannot take any value for you, because ideally what you're trying to do, you're trying to build a sensible relationship between the xi and the yi. So xi cannot be some any random field which you're giving into the system to get a yi. If you're doing that, you won't be able to find, you let's say, uh tell me anything which only has whole number values. Let's say the runs which Sachin has code. Okay, runs which Sachin has code. We are trying to build a predictive model on that. So what I've done, I have made this. I'm making a predictive model on the runs which Sachin has code. Okay, using certain, I would say, regression variables. So one factor can be the pitch, how the pitch is. So pitch can be, flat pitch, greenish pitch, or all these variables. So that can be one variable. The wind speed also can be one variable which can impact the performance of Sachin, right? So that can be also another variable. And let's say, tell me any other variable. Number of fast bowlers in the team, in the opposite team, perhaps, right? So okay. Now let's say I'm trying to build a regression model, and I input x3 value as 4.75. which is a number of fast bowlers. Is it a relevant value for us? Can the fast bowlers be 4.75? No, right? Right. So the even the independent variable cannot be any random thing. Cannot be any random thing. It has to be something which makes sense in the holistic model which has been given to us. Otherwise, we are always going to get a spurious, a model for us, which won't make any sense. So that's why independent variable can also be not random. Okay, and those independent variables cannot have correlation amongst themselves. So this is also very important because जब हम मॉडल्स में करेक्शन बिल्ड करेंगे we'll move to the correction also where we are trying to improve a given model. So when we try to improve a given model, we are also going to see what are the errors in the model. So remember one thing very clearly, that these values x1, x2, x3 cannot have any sort of correlation amongst themselves also. There cannot be any correlation amongst these independent variable amongst themselves also. Okay? ठीक है. Do you have the reading with you?
I think I have the Kaplan access. The books haven't come in.
Okay. Okay. ठीक है.
Can open it.
So let me do one thing. You can also log in into your system, and I'll also share on my screen so that you are able to see the example. There's a very
Oh,
good example over here in Kaplan.
the LOS
Oh,
1D, no, it is.
no, it's LOS C.
Module 1.1.
Yeah, model 1. It's book 1, model 1.1,
Got it.
right? So come to LOSC and just read this, office rent model once. Read this. So analyst is basically trying to determine the rent for office properties in a large city in US, right? And there's a sample of 191 observations. So what do you think? Is it a big model or is it a big sample size or is it a small sample size?
Relatively big.
Relatively big because it's obviously more than 30. So as per the statistical knowledge that we have, more than 30 is a good sample size, right?
Hmm.
So he has built a model on certain factors. Let's try to understand what these factors are. Rent is a dependent variable and it is dependent on three factors. One is the age of the property, like how old is the property, distance from the nearest metro station, and third variable is very interesting, which is the number of restaurants within that particular geography. Okay. So on the basis of this, we are determining the rent of the office properties in the city of US, in any particular large city of US. I hope the model is clear,
Yes.
right? So when the analyst has tried to build the predictive model, he has come up with these particular values, the coefficients, the estimates. So estimate is showing what is the coefficient value. Okay. So age का coefficient is -0.31, distance का coefficient is -0.01, and the coefficient for restaurant is 1.29. We are okay with that. A regression can take any value. Let's try to move beyond this. Do you remember what is standard error?
The square, no, of the error term.
No. Yeah, that was one standard error. The standard error in this case is the जो यहाँ पे standard error दे रहा है, that is for the coefficients.
Okay.
Okay. Okay. Now see the plot of residual versus predicted values. So on the x-axis you have the predicted values, okay, and on the y-axis you have the residuals. As per the assumptions which we have read just now, what sort of relationship can be there between the residuals and the predicted values? Just read the assumptions. There cannot be any major relation between the residuals and the predictive value. Okay, first. Okay. So this is one plot. Now plot of residuals in the independent variable. So these are the xi's and these are the residual values. Okay. So you can see how they are moving. The residuals are for all observations. The variance can be, figured out. Okay. Okay. These are residuals with respect to the each variable. So residuals with age, residuals with restaurant, residuals with distance. The three variables which we have. Okay. Jeremy, are you comfortable with this till now? Yeah. Any issue?
No, it's fine.
Okay. Now just open a normal QQ plot of residuals. So this is the QQ plot of residuals, which I'll tell you, how this is utilized. Okay. Now the first question which they have given, interpret the plot of regression residuals versus the predictive value of the dependent variable as shown. Okay. So the regression plot of residuals. Okay. This is this one, the first one. Okay. I'll stop. Have you opened the computer?
Yes,
Okay. So can I stop sharing so that I can use the writing pad?
got it. Done.
Okay. Take it. Perfect. Okay. So as you can see in the plot of residual versus the predictive values, you don't see a systematic pattern, right? I am not able to figure out any sort of direct relationship between the independent variable and sorry, in the dependent variable and the residual values. So this, is basically what I wanted, that there should be no relationship between the predictive values and the in the residuals. There should be no correlation between the residuals and the predictive values, which is what I essentially wanted at the first place. Which is what I essentially wanted at the first place. There should be no sort of relation between the predictive values and the residuals. Now come to the second question. Come to the second question. What can you say about the second part, please?
There is a there is a relationship for age and restaurants.
Asian restaurants.
You say exhibit two, no, you're saying?
Yeah, yeah, yeah.
The first two are displaying a sort of uh, the points are in between a range.
So for the residuals and the independent variable, if you see over here, there seems to be no relation. Obviously, the range is there, which is good for us. That the residuals are not going scattered with respect to the independent variable, which is okay. But do you see any increase in the residual values as the value of the independent variables increasing, or do you see any decrease in the residual values as the value of the independent variables decreasing? Do you see any such kind of thing happening over here?
No.
No, right? So there's no exact relationship between the independent variable and the residuals, which is what we wanted at the first place. So age is clear.
Hmm. Yes.
The scatteredness of this is okay. Scatteredness का issue नहीं होता. If they are widely scattered, then it would have been a problem. But if they're scattered within the range, that's in fact a good thing. That's in fact always a good thing.
Hmm.
Because you don't want your errors to spread out in the entire model. If you're making such kind of model in which errors are scattered out, that means you've built a bad model. Now think of it in very easy terms. Samjho. Now let's say I build a model whose this is the actual values and this is the predictive value. So actual value is 10, predictive value is 100. Actual value is 12, predictive value is 20. Actual value is 13, predictive value is 45. What is the error term going to be in this case? First error term is going to be minus 90, minus 8, and minus, let's say, 32. And if you plot it, so for 10, it is going to be minus 90, somewhere very down below. Okay. So, and for 12, it is going to be minus 8, so somewhere like very close over here. And for 13, it is going to be somewhere in the middle. Now, my error terms are totally scattered on the plot, which is the worst thing for any analyst who's building a predictive model. which is the worst thing for any sort of analyst which is here. I hope you're able to understand my point,
Yes, sir.
right? It makes sense for you as well.
Hmm. Yes.
Hi Rohit, hi Agree Thinking. I hope you're able to understand. So this is, basically us trying to interpret the residual models which is given to us, which is being given to us. Okay. Okay. Come to question three, please. The QQ plot. First, just see what is, given the QQ plot. Just try to understand those terms for like 1-2 minutes. Okay. Then I'll, help you with the QQ plot as well. Don't worry. Okay. Have you seen that now?
Yes, sir.
Okay. So QQ plot is basically used to plot the residuals, and the objective of the QQ plot is to understand whether your residuals have a normal distribution or not. If you see, if you remember, basically the discussion which we had with respect to the residuals, one of the assumptions was that normal distribution normal distribution must have the residuals must have a normal distribution. So in order to check whether your errors or the residuals have normal distribution or not, we can use a QQ plot. Okay. So in the QQ plot, what we want that the QQ plot, the distribution shouldn't go beyond 1.65. So basically, it shows that if my in the QQ plot, if I'm going beyond the minus 1.65 range, if the errors are going beyond the minus 1.65 and the plus 1.65 range, then that there is some sort of skewness in the model, some sort of skewness in the model, which means that the distribution is not the errors are not following a normal distribution. I hope it's clear. So in the QQ plot, if you see, which we have in front of us, do you see observations going beyond 1.65? Do you see observations going beyond 1.65?
Hmm. Yes, sir.
Right? So they're going beyond 1.65. That means that there is going to be some sort of skewness in the model, which we might have to correct. Which we might have to correct. Okay? So there might be some sort of skewness. Leptokurtic, pretokurtic, do you remember from the level one? थोड़ा बहुत याद है? Are you able to recall a bit?
No, so they have
Yes.
their peaks are
Yes.
slightly higher, lower.
Pattern tails, peaks, right?
Hmm.
So if in a given model it is going beyond 1.61, that means there is some sort of skewness, and it might be pretokurtic, leptokurtic. We might have to check for that, right? So the point remains that the normal distribution assumption somewhere impacted in the entire model. Okay? Okay. Able to follow the premises till now?
Yes.
Okay, perfect, perfect. Okay. So let's do one thing. It's 9:56 over here. Let's take a 10-minute break, 10-15 minute break, and then we'll resume the session again. We'll
Okay.
start around 10:10. Okay.
Okay.
Okay. Till the time, Rohit and Agri Singh, if you have any questions, you can ask. You can write in the chat box also if you're comfortable. If you're not comfortable speaking up. Okay, Rohit is saying, sir, not all the points. With respect to what, Rohit, can you please tell me? Okay, Rohit. Rohit, we are actually discussing this topic called multiple regression. So, what we have done till now, we have just done a warm up of. Uh, okay, okay. So we have just done a warm up of level one knowledge and build upon certain concepts of level one. Okay, so it's not something that we discuss something separate or different till now. We're just building upon our previous knowledge of the CFA level one. So that we're deploying and using it to do multiple regression now. Okay. So I'll build upon new topics now. So now you can, participate more in the class and ask questions whenever you feel like. Okay. Okay. So we are taking a 10-minute break. We'll start at 10:10. You can have some water and refresh yourself till that time, and then we'll start again. Okay. The audio video is fine. I hope the audio video is fine, everyone. Okay, take it. Thanks. So now we are moving to a topic called as ANOVA table. Called as ANOVA table. And in the ANOVA table, see, ANOVA table is something that we have used in the previous level as well, right? So again, it is coming back to haunt us. If you feel uncomfortable with this, and if you feel comfortable with this topic, and this is going to be cakewalk for you, right? So do you guys remember why do we used to use ANOVA table in our analysis? What was the purpose of that? What do we use ANOVA table for? So the purpose of ANOVA table used to be that we used to calculate, or we used to try to understand what is the component of the explained variation which is there, what is the component of unexplained variation, and understand the component of explained variation, understand the component of unexplained variation. In the total variation, what is the component of explained variation, what is the component of unexplained variation, and accordingly understand whether the model that we're using, is it a good fit or is it not a good fit. And we used to calculate something which we used to call as R square also. R square. Do you guys recall that a bit? थोड़ा बहुत याद आ रहा है? I hope you're able to recall that a bit. R square, right? Jeremy is looking totally blank right now. So that's okay. That's not a problem. Anyways, we are going to revise, and it's okay if you've forgotten. As we go into the topic, you shall be able to recall most of things. Okay? Don't worry. So in a ANOVA table, so I'm drawing ANOVA table for you again, so that you feel comfortable with this and you're able to take yourself beyond the concepts. Okay. So this is one regression equation. This is regression. This is error. Okay. Like how we used to draw it. This is degree of freedom. DF means degree of freedom. So in for the regression, it used to be K, and for the error, it used to be N minus K minus 1. N minus K minus 1. Okay. This is total. Total of this shall be N minus 1. Total of this shall be N minus 1. Okay. Abhi, I'll explain everything. What is K, what is N, and like everything. So don't worry. Be patient. Okay. Then there's sum of squares. Okay. Sum of squares for regression. So this is called as RSS, regression sum of squares. This is SSE, sum of squares error. And this is the total of this is called as sum of total variation. ठीक है, ये total sum of squares ही बोल सकते हैं, whichever way you feel like. Okay. And when we divide SS by degree of freedom, SS by degree of freedom, we used to get a term which is called as mean sum of squares. Mean sum of squares or mean square. Mean sum of squares or mean square. So RSS divided by K is RSS divided by K is mean square of regression. This is MSE, mean square of error. Okay. This divided by this is mean sum of regression. This divided by this is mean square of error. Acha, do you remember, if you're able to recall, that's good. Do you remember what was root MSE? Under root of MSE? What was that? What was root MSE? So this is small homework for everyone, that once the session is complete for today, just go and revise linear regression once. Just open that book, skim through. Okay, just skim through quickly, so that you are able to get a hang of it. Okay, so you're able to get a hang of it and you feel comfortable with the topic. Okay, and it is important. It is important because then snowball effect shall be there otherwise. Okay. I hope till this point you're clear how we are building a ANOVA table. I would want you guys to note it somewhere quickly if possible, so that once we get into the questions and get into everything, you know what are the components. Okay, okay. Just note it very quickly. I generally don't ask you to note down anything, but sometimes it is important to have something in front of you somewhere written. Okay, so take 2 minutes. फटाफट note down कर लो. 90% of the time I never ask you to note down everything, but this is a bit important. Okay? That's why I'm asking you. Because I want us to solve some questions also.
Yes, sir. Done.
Done? Okay, perfect. So now let's come to the discussion on R square. R square used to be RSS divided by TSS or SST, whichever way, like whichever notation that you keep. In different books, you will see different names for the same thing. In some way, it is written TSS. In some way, it is written SST. But the objective and the underline remains the same. That basically what you're doing, you're dividing this component we're dividing this component with this component. Now, why we are doing this? Why we are doing this? We are trying to understand how much of the how much of the total variation can be explained, with a given regression model. With a given regression model, how much of the total variation, can be explained with the help of a given regression model. Acha, with this premises and with this knowledge, what do you think? With this premises and with this knowledge, what do you think? The RSS value should the R square value should be high or R square value should be low? R square value should be high or R square value should be low?
So high.
Exactly high, right? So the R square value should be as high as possible to because if we are able to explain as much variation as possible in a given regression model, then we can say that the model is a good fit. The model is a good fit for us. The model is a good fit for us, or there's what we can say as goodness of fit. Goodness of fit. What does goodness of fit mean, sir? Goodness of fit means that I'm able to build a model in such a manner that I am able to get all the predictive values, most predictive values close to the actual realized value. So generally देखो कैसे एक regression model build होता है, just try to understand that once so that the line which I have said right now makes more sense for you. So generally what happens, you are given a data, you are given a huge amount of data. So you are given a sample data first, and then you use some of the data to check whether your model is working fine or not. So let's say आपको अगर 100 values दिए, you divide that 100 values into two parts. One part shall be used for building a regression line. Okay? Once you have got the regression line, then you use that regression model to predict using the next 50 values which you have. I hope you are able to understand my point till now, right?
Hmm.
So
Yes.
you're trying to see that the model which you have built till now, whether it is able to make good predictions for you or not, whether it is able to explain most of the variation or not. उसका मतलब वही है. That is the meaning of that only. That whether you are able to explain most of the variation or whether you are able to make good predictions with the given model. Whether you are able to get values which are close to the actual value till now with the data which we have. First testing is always done on the data that we have, right? To get an understanding, okay, the model is working fine. Then we deploy that model in the real life and circumstances to make sure that the model is working fine and you're able to get some tangible real output out of this. Okay. Okay. Now R square. R square, basically higher value of R square tells you that the model is much better. The model is much better. It is able to explain most of the variations which are possible. Most of the variation which is possible. But there's one problem. There's one small problem with this. There's one small problem with this. That problem is that if you're using R square, and since we are using multiple regression model, if we are increasing the number of variables in the multiple regression, the number of variables is definitely going to be high. Number of variables is definitely going to be high. So if we are increasing the number of variables, one of the problem with the model is that As the number of variables are increasing, that means x1, x2, x3 are increasing, r square also starts increasing. R square also starts increasing. Do you think in that case we should ideally use an R square? हमें उस केस में R square use करना चाहिए क्या? What do you think?
No.
Obviously not. Yes. Obviously not, because अगर if in my given model, if in my given model, as the R square keeps increasing with increasing number of variables, that means that what will happen? So as I'm increasing the number of variables, R square is increasing, so I might include even those variables which doesn't have any statistical significance. Let's say I was making a predictive model on this runs with Sachin's code. Okay. Now it is a model yi naught which is based on, let's say, b naught plus b1 on the weather, on b2 uh, air speed, wind speed on that day, plus b3 number of bowlers, fast bowlers. Okay. And let's say b4 number of hours Jeremiah has slept. Okay. Okay. But in that case, if I keep including more variables, the R square shall keep increasing. Although this has no relevance to this. This has no relevance to this. But even then also this R square shall increase. And that shall make my model spurious. Right? So in order to remove the such stupidity in the model, in order to remove any sort of variable which is not relevant to the whole analysis, instead of R square in the case of multiple regression is a highlight. Okay, we are doing multiple, not linear. So in the case of multiple regression, instead of an R square, we use another term or another different term which is called as adjusted R square. यहाँ पे हम क्या use करते हैं sir? We use adjusted R square instead of R square for explaining the variation, for understanding how much variation in the model can be explained. Everyone able to understand and follow the concept till now? Please tell me if you feel any discomfort with the topic. Okay. ठीक है. See, I generally appreciate, if you keep speaking along as I go or ask questions. So in that case, the whole flow is maintained and everyone is able to, understand things. Okay. So if you feel any discomfort with the topic, speak up. That's totally okay. Okay. We are all trying to learn something about it. Okay. Okay. Acha, just one small thing. Okay, you want me to go slow? Okay, fair enough. Agree thing. I don't know your name, but do you want me to repeat something? Alpesh. Okay. Alpesh, do you want me to repeat any given topic? Any given thing which we have discussed just now? Okay, fair enough. Okay. So in the case of multiple regression, we use adjusted R square instead of R square. And why do we do that? Because we want to avoid a situation. We want to avoid a situation which is called as overfitting, the model. Overfitting. इसका मतलब क्या होता है? What does it mean, sir? It means that I am more variables, putting in more variables than even required, required, than even required. Because in the case of R square, it shall keep increasing as the number of variables are increased, as the number of the independent variables are increased. So there might be a situation where I might make a very big model, where I might make a very big multiple regression equation. I might make an equation which could look something like this. Y hat is equal to b naught plus b1 x1 plus b2 b2 x2 plus b3 x3 plus b4 x4 bn xn. But Let's say I might not even need this part. This part might not be even relevant to me, or the explanation of the variation which is being done by these part is already being captured by this. But since my R square, but since my R square kept increasing, since my R square kept increasing as I included these variables, I kept increasing the number of variables. So in order to remove such kind of situation, I use something which is called as adjusted R square. I use something which is called as adjusted R square. Now, what is the formula for R square? Adjusted R square? Okay, just look over here. What is the formula? The formula for adjusted R square is, and the notation is R square A. Okay, to denote adjusted R square. R square A is equal to 1 minus bracket n minus 1 upon n minus k minus 1, okay, into 1 minus r square, into 1 minus r square, where n equals to the number of observations and k in the entire regression which you will study, k always denotes number of independent variables, number of independent variables, okay, number of independent variables. So what is the specialty about adjusted r square? In the adjusted R square, if you're increasing the number of independent variables, if you're increasing the number of independent variables, your this factor, your this factor shall get increased. ये आपका ये जो part है, this shall increase, and since it is getting subtracted from 1, your adjusted R square shall decrease. Your adjusted R square shall decrease. So that's why it is always advisable that you only include those variables which have good explanatory power in the model. Which have good explanatory power in the model. Only those variables have to be included in the model. Only those variables have to be included in the model so as to avoid any situation of overfitting. So that we can avoid the situation of overfitting. I hope you're able to understand and follow Jeremiah, Alpesh, and Rohit. Comfortable till now?
Yes.
Oh, perfect, perfect. So that is adjusted R square. Okay. Okay. Let's do a small calculation. Okay. So that we all feel comfortable with the topic. So I'm just putting out a question for you in the chat box, and people who might see the recording as well, I'll write it down over here also so that. Okay. I've put the question over here in the group. Okay. I'm writing it on the screen also. So the question says that an analyst is running a regression of monthly stock returns on 5 independent variables. So there are 5 variables on which this regression is being run. Okay? 5 independent variables. Okay. So what we are trying to predict? We are trying to predict stock returns, monthly stock returns. Okay. We're trying to predict monthly stock returns. There are 5 independent variables that we have, and the data that we have is of 60 months. Data that we have is of 60 months. So now let's try to pick what are all the variables which are given. What is n in this case? What shall be n in this case? Number of observations, right? So what is n in this case?
60.
Yes, 60, right? The sample data which we have. What are the number of independent variables that we have? 5. It is given in the question, right? So k is 5. It is directly given in the question. And what we are trying to predict? What we are trying to predict? Monthly stock returns. Okay. Y, K, and N clear hai? How do we get it? Jeremiah, Alpesh, and Rohit. Do you want me to repeat anything? These are monthly stock returns, K and N. Till now, comfortable. How did we arrive at these using just the first line in the question? Okay. Okay. Now let's come to the second line in the question, which says that total sum of squares for the regression is 460. Yes. Yes, Alpesh, 5 is the number of independent variables. Correct. Correct. That's why K is 5 over here. Okay. The total sum of squares for the regression is how much? 460. And the sum of squared error is 170. So what are these values? Can anyone tell me what are these values?
So SSE and SST.
Total sum of squares for regression, right? Total sum of squares is how much?
460.
Very good. 460. And sum of squares error is
170.
170. So what is RSS in this case?
290.
460 minus 170, which is how much?
290.
290. Okay. Can you calculate R square and adjusted R square now? You have the formulas. Please try it once. Please try it once. Take 2-3 minutes. Take 2-3 minutes. I have given you most of the question. I've given you most of the methodology. I just want you to put in the numbers and come to the answer, please. Alpesh and Rohit, please try. If you want me to put in the formula again, I'll just write it down for you. I'm just writing down the formula for adjusted R square so that you don't feel out of place. First calculate R square, then calculate adjusted R square. Okay.
Yes, sir. Done.
Done. Okay. Alpesh and Rohit, done. Okay. Alpesh has given the answer. 0.6304, which is around 63%. Is that the answer for the R square? And adjusted R square is 0.50. Jeremy, what's your adjusted R square?
Got 0.5962.
Okay. Well, there's a difference in the answer. Okay, let me also solve with you. Okay. So first, let's calculate what shall be R square. Okay. R square shall be pretty straightforward. R square shall be pretty straightforward. You just have to divide 290 by 460. 290 by 460. So RSS divided by TSS, just 290 divided by 460, which is how much?
0.6304.
0.6304, which is around 63.04%. Okay. So that is my R square. Now I want to calculate adjusted R square, right? That shall be 1 minus n minus 1 upon n minus k minus 1 into 1 minus R square. Sorry, into 1 minus R square, right? Okay. So this shall be somewhat like this, equal to 1 minus n is how much? 60?
60.
60 minus 1 divided by 60 minus k is how much?
5.
5. 5 minus 1 into 1 minus R square is how much?
0.6304.
0.63. Okay. This becomes 1 minus big bracket 59 divided by 60 minus 5, 55 minus 1, 54 into 0.37. Right? This is how much? Solve this part first. This big bracket
0.4043.
0.4043. So this shall be equal to 0.5957. Am I correct?
Yes.
Right? So this shall be equal to 59.57%. I hope you're clear.
Yes.
Now there's one very interesting thing in this, that adjusted R square is less than R square. And this shall be the case in most of the situation, or I would say in almost every situation, because you are getting reprimanded for including any additional variable in the whole system. Okay. Rohit has a question, sir. Adjusted R square, please show again, sir. 1 second, I'll show it to you. So I have just put in the values. N minus 1 is 60 minus 1, n minus k minus 1 is 60 minus 5 minus 1, and into 1 minus R square, 1 minus 63. So I have solved the bigger bracket first. So this is 59 by 54 into 0.37. This is 1 minus this, which is this value. I hope it is clear now. Now let's move to the next part, which is to understand and interpret, a bit more of this. So for that, now we add one more question to this, which is that let's say I have added four more variables to this. Okay, and when I'm adding four more variables, my R square has increased to 65%. R square has increased to 65%. Now you have to tell me that whether should I add these four variables or not. Okay. Now tell me कि ये मेरे को चार additional variables add करने चाहिए. Should I add these four variables or not? Now give me your logic, analogy or calculation, whichever way you feel. I've added four more variables because of which my R square has increased to 65%. Now you have to solve or tell me whether this should be done or not. How will you approach this problem?
So the reliability has increased by adding the four more variables.
Okay. But Jeremiah, we just discussed one thing that in the R square, if we add more variables, naturally R square is going to increase. I hope you agree with me,
Hmm.
right? That's why we use another variable called adjusted R square, correct?
Hmm.
Right? So ideally, what should I do in this situation? I should first calculate adjusted R square to see that whether, sir, my adjusted R square has increased or not, correct?
Hmm.
Right? So my attempt or my first approach towards this question should be that I should try to first calculate adjusted R square and then arrive at a conclusion.
Oh,
Okay,
yes.
so I would want you guys to calculate adjusted R square in this situation. Please do that. Please do that.
Yes, 0.64, 0.49.
Okay, Jeremiah is saying 0.64.
Hmm?
0.64 is your answer.
Yes, sir.
Okay, Alpesh is saying 78.9%. Okay. Rohit, were you able to calculate the answer? ठीक है, ठीक है. No problem. So let's try to attempt this question. My adjusted R square formula is 1 minus n minus 1 upon n minus k minus 1 into 1 minus R square. Right? Rohit is saying, sir, 65%. Okay. ठीक है, Rohit. Let's check. Yours is 64%. ठीक है. 1 minus n is again how much? 60. That hasn't changed. 60 minus 1 upon 60 minus what shall be k in this situation? K कितना होगा मेरा? What shall be k in this situation? I have added four more independent variables. I had initially five independent variables. I have added four more. Now, how many independent variables are there? Nine. Okay. So this shall be 9 minus 1 into 1 minus r square. R square is how much? 65%. Okay. This becomes 1 minus 59 upon 50 into how much? 0.35. Okay. Now just solve it. Please tell me the answer. Please tell me the answer. 59 divided by 50 into 0.35. So this should be, I think, 1.18 into 0.35. What is the answer, Jeremiah?
So total it's coming to 0.58%, 58.7.
58.7%. Rohit and Alpesh, can you confirm? Are you getting the same answer? Rohit and Alpesh getting the same answer? No? Why? 59. That's pretty easy. 1 minus 1.18 into 0.35 is what you have to do. Just go on the calculator. Okay. And all you have to do is 1.18 into 0.35 minus plus 1.587. 0.587 essentially what? 58.7%. That's it. So our adjusted R square after adding four more variables. After adding four more variables is how much? Is 58.7%. Now what does it mean for us? Now what does it mean for us? When we had five variables, what was the R square, adjusted R square in that case? When we had five independent variables, what was the adjusted R square in that case? 60 or something, right? I don't exactly remember. 1 second, I'll just tell you. It was somewhere around 59.6. But when I have nine variables, my adjusted R square is 58.7. Do you think we should add these four variables now? Do you think we should add these four variables? Does it make sense? Does it make sense? Yes or no?
No.
No, obviously. Because my adjusted R square is falling. Now my adjusted R square is falling. So in that case, it doesn't make any sense to add these four additional variables into the system form. Into this, there's no sense of adding this four additional variables in the system form itself. Okay? And that is why I won't use these four additional variables here on. Okay? Now everything in life has a problem, and this adjusted R square also has the problem. Okay? This adjusted R square also has a problem. Uh, adjusted R square का सबसे बड़ा problem क्या है? What is the biggest problem with adjusted R square? Is that it basically penalize for overfitting. ठीक है? It penalize for overfitting. That is using more variables than required. But when it comes to making a good model or a competing model, or I would say a model which can quantify a good fit, or which has all the properties of a good fit, plus have good predictive power, which has good predictive power, okay, which can have good prediction, or we can make good predictions with that model. In that scenario, this adjusted R square fails. In that scenario, the adjusted R square fails. Okay. If I want to have good forecast with the model, or if I want to make a model which has good forecast, capacity, and which can have good, goodness of fit, better goodness of fit compared to the existing model. In that case, the model which I'm getting using adjusted R square is generally not good enough, and hence we use two other, I would say variables or two other matrix which we use to arrive at a good model, which are known as AIC and BIC. AIC and BIC. So AIC is used if I want to have a better forecasting model. If I want to have a better forecasting model, and BIC is used. BIC is used when my goal is to have a better goodness of fit. Better goodness of fit. If I want to have a better forecasting model, then I would use AIC. If I want to use better goodness of fit, then I'll use BIC. Okay. Now this EIC and BIC, how these are used, how they're deployed in the system, what test that we have to do, that is the second part on which I am coming to right now. Acha, till now, are you getting comfortable with R square, adjusted R square, and the concept of AIC and BIC till now? Any doubt or problem till now?
So what is the problem with adjusted R square? I didn't understand.
Adjusted R square, देखो सबसे बड़ा problem क्या है that let's say I want to have a model which can make good predictions, right? Now I have arrived at a model which is at least explaining the current variation. Okay. But I want to have a model which can be used for better prediction as well. I want to have a model. See, there are two things always. One is the model which can be used on the current set of data. Okay. And this one model which can be used on any set of data, it will make good predictions. I hope you're able to understand. One model which I have made using the current set of data, and it is working fine on the current set of data. But when I'm using that model for making further prediction, that model is failing blatantly. So in that case, I would more prefer to use a model which has good predictions, because at the end of the day, my objective is to make a model which can make good predictions or better forecast, right? That is my objective. So that's why I would, instead of instead of just focusing on a model which I've arrived using adjusted R square, I would prefer to analyze models using AIC and BIC as well, so as to make sure and so as to be confident कि यार अगर मैं कोई model use कर रहा हूँ, if I'm using a given model, what are the AICs and the BICs? If they are good enough, then only I should go ahead with that particular model. Otherwise, I would not prefer to go with that particular model. I hope I am able to make sense for you,
Yes.
right? Okay. So there's a small example given. Can you come to module 1.2? And I would request you never to, see answers. Otherwise, the whole purpose of that process gets defeated. Okay? Try to avoid them as much as possible. Come to goodness of it. It's after basically LOSD में towards the end of, like, this example given on the rental prices that we were doing. उसी का ही एक further example है. So, should I share my screen if you want? Let me share my screen
I
only.
haven't found it, sir.
Yeah, that's why I'm thinking, I should share my screen. Able to see now?
Huh.
Okay. Now this is the same rent wall example which we had. Okay. I'll just use a marker on the screen. Okay. This is the same example which we had. Okay. Independent variable first for the first. So we are given three models. उन्होंने बोला कि हम आपको तीन मॉडल देखते हैं. तीन मॉडल से you tell us which model you are going to use. Okay. Amongst these three models, you tell us which model do you find more suitable for using in this given situation. The first model they have made just on one variable, which is age. So using age, they are predicting the rent prices in US. Okay, that was the first model. So this is our first model. Okay, this is my first model. This is my second model, and this is my third model. Okay, in the first model, only one variable is used, which is age. On the basis of age, what is my R square? 9.23. What is my adjusted R square? 8.75. And this is my AIC and this is my BAC. This is my AIC and this is my BAC. Okay. Now when I'll just shift you guys over here on my screen. Okay. Now when I'm using two variables, age plus distance. Now from simple regression, I'm moving to multiple regression. Now I'm using two variables, age plus distance. Okay. So I'm building a model. Let's say y1 not equals to a naught b naught plus b1 x1 plus b2 x2. Okay, where x1 is age, x2 is distance. Okay, in that case, my r square is how much? 58.27, and my adjusted r square is 57.8. So adjusted r square is definitely increasing, right? Now AIC is 839.4, which is quite high. Okay, but less than what we had earlier. And BAC is 849.2. 849.2. Okay. The model which has the lowest AIC, that is generally preferable, more preferable. Okay. And the model with the least BIC, that is generally more preferable. So AIC, BIC जितना कम हो उतना better है हमारे लिए. So in that case, this is less than this. Okay. This is less than this. Okay. And this is also less. This is also less. This is also less. This is also less. Okay. The AIC and BIC are falling. That is a good indication. When I'm using three variables, age plus distance plus restaurants, in that case, my R square is increasing. Definitely, it is increasing. And R square is naturally going to increase as I'm increasing the variables. R square is going to increase. We know that. I hope you're comfortable with this line, right? My adjusted R square is also increasing. That's a good indication. If adding more variables, adjusted R square is also increasing. That means, okay, I'm having a good model. I hope Alpesh and Jeremy, you're able to understand what I'm saying. Able to follow that, right? Okay. But now see what is happening in AIC and BIC. Are they falling or are they increasing? They are falling, right? Right. So
Yes.
if they are falling, that means AIC and BIC are falling. That means that's also a good indication. So my adjusted R square is increasing. AIC and BIC both are falling. Right. Now let's come to the question. Now the model is asking which model is more appropriate for generating forecast. Generating forecast. So forecast के लिए I want to check the model with the lowest AIC. Which model has the lowest AIC in this case?
So 3.
Third one, right? So definitely we are going to use the third model when it comes to having a model with a good forecast. And better goodness of it is always in BIC. Okay. So which model has the least BIC possible?
3.
Again the third model. Again the third model in that case. So for everything holistically, I am always coming down to the third model, adjusted R square, AIC and the BIC. जरूरी नहीं है it will always be the case. There might be a situation where a certain model might a certain model might have higher adjusted R square and certain model might have lower AIC and BIC. So in that case, you have to make certain model specifications to make sure you get the best model for your particular use. Okay. I hope you are able to follow till this point. Anyone need doubt? Rohit, Alpesh? Okay. I'm sharing my screen for the writing pad now. Okay. Okay. So this was R square, adjusted R square, AIC and BIC. Okay. Now I'll try to summarize it so that you are able to capture and assimilate whatever we have taught, because I know this is the first class, might be too much information TMI for you for the first class. Okay. You might not be able to recall everything. So I'm just trying to summarize whatever we have done till now. So to put it in a summary format for you, what we have done, we have understood what is regression, how do we build a prediction model, what is the significance of the coefficients which is there. Okay. We have also understood the ANOVA table. We have understood using ANOVA how do we calculate R square, adjusted R square, the relevance of both R square and adjusted R square, and then we have understood what is AIC, and then we have understood what is BIC, and which model to use in what given situation. If I want to have a good predictive power in the model, then I'll use AIC. If I want to have a model which has better goodness of it, then I'll use. I hope it is making sense a bit for now. No. Okay, sir. I have found out a model which has good predictive power and everything. But my objective is to have a model which has multiple regression, but I don't want to calculate AIC, BIC. I want to use something else. I want to use certain different methodology to understand whether I should add a given variable or not. Whether I should add a given variable or not, मेरे को वो करना है तो मैं वो कैसे कर सकता हूँ? How do I, you know, create such scenario, or how do I arrive at this situation that adding more variables making sense or not for me? How do I calculate that? So for that, we come to LOSE, in which we try to understand something which is called as a nested model. Okay? देखो, all they have done is to increase our vocabulary. The logic pretty much remains the same. Honestly, the logic pretty much is same. There's no change. Ideally, what you would have done. Okay. Yi equals to B naught plus B1 x1. Yi are Jeremiah's marks, and xi is his number of hours he spent in starting. So study time. Take a study hours. So I have built this regression equation. Now Alpesh comes and says ki Jeremiah, the model which you have built is faulty. There's some problem with this model. Ideally, you should add one more factor. Ideally, you should add one more factor. So Jeremiah says, I should add one more factor. Yes. Now let's try to understand what this factor is. He says that Jeremiah, add one more factor called as, let's say, hours you have slept. Hours you have slept. So if you had a good sleep, that's a good indicator. If you have a bad sleep, that means there's some issue. So do one thing. Let's build one model which is called as the restricted model. Restricted model shall have only one variable which you have used till now, which is b0 plus b1 x1, which is the model that Jeremiah has built initially. That is the restricted model. Now, since Alpesh has a problem with this model and he's saying ki nahi, nahi, you have to use one more variable to check to build a more holistic model. So, using Alpesh's suggestion, we build another model which is called as the unrestricted model, which is the unrestricted model, which is b0 plus b1 x1 plus one more variable b2 x2. B2 x2, that is the unrestricted model which we have. In the case of restricted model, there's only one independent variable. In the case of unrestricted model, there are more number of independent variables. Okay. I hope it is clear till now. Anyone any doubt? So this is more simple model and this is more complex model. Since it is more simple, it is called as parsimonious. Parsimonious. Where I'm trying to reduce the complexity in the model. This is more complex. So it is non-parsimonious model and this is a parsimonious model. Now my objective is to understand that if adding one more variable is making any sort of impact in my analysis. If this additional variable is making any sort of impact in my analysis, so what I will do, I will do a hypothesis test. I will do a hypothesis test where my H naught shall be that b2 is equal to 0. This additional variable has no statistical significance, shall be a null hypothesis, and my alternate shall be that this has some sort of statistical significance. इसकी कोई statistical significance है. अब मेरे को f test calculate करना है. तो f test calculate करने के लिए मैं क्या कर सकता हूँ? I can just use this statistic, which f statistic, which I'm going to write for you, which is SSE for the restricted model minus SSE for the unrestricted model. Okay, divide this whole by Q. Okay, divided by SSE. I'll just try to below ताकि थोड़ा साफ रहे. SSE of the unrestricted model. SSE of the unrestricted model divided by n minus k minus 1. Restricted model कौन सा था जिसमें where there were more variables, where there were only one variable, which was a parsimonious model. ठीक है. Unrestricted कौन सा है where there are more variables, more independent variables. There is only one independent variable in the restricted model. I have restricted my model to only one variable. That's a restricted model or a parsimonious model. Unrestricted model कौन सा है where there are more number of independent variables. I hope you are clear till this point, everyone.
So what is this F?
Sorry, what is this?
F?
F test.
Okay.
We used to do F test, right? Hypothesis, right? So that is that F. Okay. And Q and n minus k minus 1 degree of freedom that we used to use.
Okay.
Right? Okay. Q is basically the addition, the number of variables which have excluded in the independent in the restricted model. So in the restricted model, I had only one variable. In the unrestricted model, I have two variables. So how many variables I have excluded in the restricted model? I have excluded one variable. So Q shall be 1. If I had, let's say, 3 variables in the unrestricted model, then my Q shall be how much? 2. Alpesh, Rohit, able to follow? Comfortable till now? Should I repeat something? Able to understand? Please type yes or no, or you can say it also. Okay, fair enough. Thank you, Alpesh. Rohit, you can write in the chat box if you're not comfortable with anything, or if you're comfortable, I can move ahead. I know the premises might sound, larger than life and more, yeah, you might feel that it's a different world altogether. Go slow. Okay. Alpesh, do you want me to speak slowly or like take the topic a bit slow for you? So sometimes you go fast within a topic. Okay. Okay, I'll try to, navigate that feedback taking. I'll try to make sure that. Okay. So my objective is that if I'm using only one variable, what is the, difference when I'm using, let's say, two variable, three variable in my whole analysis. So let's say if I build a model with three variables and if I build a model with one variable, how many variables I have excluded in the restricted model, which is restricted to only just one. If I'm using three variables, I have excluded two variables. Okay. So my Q shall be how much? Q shall be two. Okay. Jeremy able to follow till now? Okay,
Yes,
man.
sir.
Okay. So all I have to do is make this test statistic and arrive at the value and then do a check on the same. Do a check on the same. Now, how will I do it? Let's understand it with the help of a example which is given in the book. So, I would want you guys to come to module 1.2, LOSD, LOSD, and there's an example given. All of you have access to Kaplan, or should I share my screen or something? Let me know. If you have access to Kaplan, that's good. If you don't, then I'll share my screen. No access, Alpesh. Okay, fair enough. I'll share my screen in that case. Okay. I hope it is visible. Okay. Now we are continuing with the rental example only. Now you have to do a hypothesis test for slope coefficient at 2 and 3 at a 5% level of significance. Okay. Okay. Perfect, Rohit. Now in the unrestricted model, how many independent variables are there? Three. In the restricted model, which how many independent variables? There's always going to be one in the restricted model. So what shall be Q in this case? What shall be Q in this case? Q कितना होगा?
Two.
Exactly 2. Because Q is the number of excluded variables in the restricted model. In the restricted model, I have only used one, but in unrestricted model there were three. The difference is of two. So I'll have two uh two as my Q over here. Okay. Okay. Second. Huh. Now what I have to do, I have to do a F test. I have to do a F test. At what level of significance? 5% level of significance is what I have to do the F test at. Okay. Acha. Tell me one thing. What shall be? So Q is 2. What shall be n minus k minus 1? What shall be n minus k minus 1? Just to recall, n is 191. K is how much? 3. K is 3. Jeremy, able to follow till now? K is 3, right? So n minus k minus 1, that shall be another degree of freedom for me. So it shall be around 191 minus 3 minus 1, which is around 187. Okay. So if I have to check my F, so how will I go? Q is how much? 2. So 2 and around 187, which is close to 190. So this shall be my F value. This shall be my F value from which I will evaluate the statistic value which I am going to get. From which I am going to evaluate my statistic value. Okay. So this is the F value and I am going to evaluate my statistic value and compare them and then compare them. Okay. Okay. Now what I have to do, I have to first calculate the F statistic. I have to first calculate the F statistic. So what you should do now, try to calculate F statistic. Okay, I'll just share the values now because some of them don't have access. Let me share the screen again. Okay. So just quickly note down these values, everyone. Quickly note down these values, please. अनरिस्ट्रिक्टेड में इसमें ये क्या आ रहा है, के कितना है, एसएससी कितना है, एन कितना है, जस्ट नोट इट डाउन समवेयर क्विकली प्लीज, so that now you can go on to the calculation of F statistic. Alpesh done? Rohit done? Have you noted this table? Only this one, the small one. Model, unrestricted, restricted, K and SSE and N. That is all you require for the F test. Done, Alpesh? Okay. Okay. I'm, stopping the screen share, and I want you guys to start solving. Calculate the F statistic value. If you want me to write down the formula properly for you, or remove whatever I have written over here once. Okay. So all you have to do is input the values. SSE of SSE of the restricted model, SSE of the restricted, SSE of the unrestricted divided by Q, or SSE of the unrestricted upon N minus K minus 1. So you have to just input the values over here and arrive at the F statistic. Tell me the value. How much is the F statistic, please? Please solve this.
So what is SSEQ?
So SCU, I have written Q. 1 second. I'll just, this is U.
U, no.
SSE of restricted minus SSE of unrestricted. Okay.
The K will be 3, no?
K will be 3, correct? K will be 3. Because there are 3 independent variables, right? Okay. Done. Alpesh and Rohit. Okay, very good. Awesome. Rohit, were you able to do it? Now, in this case, our F value is 131.63. But as per the table, our F, as per the table that we had of the F table, the F value was coming out close to around 3. But our values coming, F statistic coming beyond 3, it is 131.63. So definitely we are going to reject a null hypothesis in this case, which was that B2 equal to B3 equal to 0. This is going to get rejected. This is going to get rejected. And we can say that one of these variables is obviously statistically significant and different from 0. So, and that means that we have to include more variables in our model specification. We have to include more variables in the model specification, right? So in that case, we have to use a unrestricted model instead of a restricted model. And that means, and that helps us understand and make sure that whatever variables that we're increasing, they have some sort of importance or significance in our analysis. I hope you are comfortable till now. Any problem, anyone? Okay. And this is the, this is the topic that we had to cover today. Apart from that, LOSF is pretty straightforward. You just have to fit in the values to arrive at an answer. So basically, just like how we used to calculate the predicted value in level 1, you just have to do that only. Let's solve one question so that you don't feel out of place in the question itself. I'm just sharing the question in the chat box. I'm just sharing the question in the chat box. Okay. The question is that we want to use regression equation to estimate the 10-year real earnings growth rate for S&P 500. Okay. Assuming the payout ratio of the index is 50%, he observes that the slope of the yield curve is currently 4%. What is the model prediction for the index real earnings growth rate? Real earnings growth rate. Okay. Now in this question, we are given the equation. I'll just write it down the equation. All you have to do is input the values. All you have to do is input the values. Okay. Now how do we do it? Just see over here. क्वेश्चन समझ में आया? Our objective is to predict the earnings growth rate for the index called S&P 500, which is the US index, right? अब इसमें we are given two variables. One's the payout ratio. X1 is the payout ratio and X2 is what? X2 is the current yield. X2 is the current yield. Okay. Now the equation that we are given is Y1 naught is equal to 11.6% plus 0.25 x1 plus 0.14 x2. Can you tell me the y1 naught or the earnings growth rate for S&P 500 in this case when x1 is given as how much? The payout ratio is given as how much? 50%, and the earning and the yield curve, current slope of yield curve is around 4%. Can you tell me what is the y1 in this case? Can you tell me what is the y1 in this case? What shall be my predicted value for the earnings growth rate of S&P 500? Jeremy, Alpesh, and Rohit, can you try to solve this, please? All you have to do is just input the values. The question is just totally in front of you. Jeremy, are not comfortable with this?
Yes, doing.
Okay. It's pretty simple. All you have to do is just input the values minus 11.6 plus
0.146. 0146.
okay. Just this. All we have to do is just this. Nothing much. Nothing much. Okay. The answer shall be around 1.46%. 1.46. That is the only thing which had to be done in this particular question. Very straightforward. Alpesh, Rohit, comfortable till now? Any problem? Perfect. Perfect. Okay. So since this was our first class, I won't take much of your time. We know that quants has given you a lot of new topics for to you to revise and understand again. So Jeremy, I can actually tell from your face also. You faced difficulty last time also in the quants, so that's okay. But this time, see the top in terms of length of chapters are not that big. Like there are lesser chapters compared to level one. Level one where we had a huge number of topics. It's just that there's a lot of detailing in each and every chapter. So that's why we need to continuously solve questions as we do one particular topic. We can't lag behind in solving questions. Okay? And that make it very clear in your head from the beginning itself so that you don't find difficulty as you are about to close your preparation. Okay? Unlike the last. Okay? Chalo. Thank you guys. Thank you for turning on the session. If you have any questions, you can ask or we are good to go. No questions, then thank you for the session and let's meet in the next class. Okay? Chalo guys. Bye bye. Have a good day.
Bye.
Bye bye. Enjoy the match.
You too.
Bye bye. Thank you. Thank you, Alpesh. Thank you, Rohit.